friends, we are here to discuss second video on microprocessor. And if you remember, I started with microprocessor introduction, and in the introduction we never discussed about anything, but I talked about syllabus that I'll follow either Delhi University BSc syllabus on microprocessor or any BTech course all over India. They're near about same because as per UGC norms 70% syllabus has to be 80% syllabus has to be same all throughout India. So it doesn't matter which university you are from, syllabus will remain almost same. I preferably speak in English because some of my students and especially from abroad also requested, but I feel more comfortable in English. But if you ask me to teach in Hindi, then I won't mind because concept is more important, language is not so important for me. So I am comfortable also in Hindi because teaching in Delhi one I need to speak in Hindi and explain in Hindi because I have handled students from UP and MP and Rajasthan who are very talented, but basically from the Hindi background. They had no English knowledge at all, so I had to explain subject like microprocessor or EMT to them in Hindi, though that was not legally permissible. Anyway, now if we see the course, and especially I'm talking about Delhi University, in Delhi University BSc where we have embedded, they simply talk about embedded course, but here I am first discussing about because number of students in embedded course in Delhi University or any other central university or state university is comparatively less. So I'll give emphasis to all the whole course so that you can see your requirement and find out your answers. So first I'll take the syllabus of a BTech course, which is also in syllabus of GATE or NET. Everywhere we have the same syllabus. You can see here we talk about microprocessor and microcontroller. In Delhi University syllabus of BSc, where we found only embedded technology. That means it deals only with microcontroller, not microprocessor. But to be very honest, to understand microprocessor without knowing of understand microcontroller without knowledge of microprocessor is almost impossible and unwise. So basics of microprocessor has to be taken. One more thing I must tell you here, in the syllabus you can see this syllabus is including 8085. In modern syllabus 8085 has been excluded in most of the universities, but even then I'd like to give description of 8085 because without knowledge of 8085 microprocessor, the knowledge of 8086 won't be complete. So first we talk about 8085, this part. We talk basics of 8085, and those who are in BSc course have only microcontroller embedded technology. They with knowledge of microprocessor will be more 8085 will be more concept, will be more clear, and handling microcontroller much easily. Only difference, the basic difference between microprocessor and microcontroller is this: microcontroller has got inbuilt memory, whereas microprocessor has got external memory. That is the basic primitive definition we can say, though there are many other differences we'll come across. 8086 is next topic, and that is the latest version, next version of 8085. This is what 8086 will deal with, and this is what we have 8085. So first we'll know the architecture, the beginning of 8085, how it works, and then some changes has been done to 8085 to declare that to be 8086. We'll deal with that. And then this paragraph you can see, this is strictly dealing with peripheral, means I'm using my laptop and I have the writing pad, I have printer, I have speaker, and we cannot make them directly without a peripheral device. Like when I write something here, I'm writing something on my electronics pad, and that has to be interpreted to my microcontroller, microprocessor of my CPU of my laptop, and that has to be interpreted by some peripheral IC device, that is integrated circuit. That is my peripheral, like 8255, and they are allocated. Some of the devices are allocated to some of the functions. One has to be very clear about the numbers, like 8259 is meant for something, and 8257 or 8237A is meant for something else. All have their different functions, and almost all of them are 40-pin ICs, like microprocessor 8085 or 8086, all are 40 pin, and we are managing them very well. Then second part is same as that of our embedded course. This is microcontroller. We are dealing with microcontroller which number is 8085 8051 microcontroller, that is the basic microcontroller. So we'll deal with that, and we also deal with some of the programming languages, what we call assembly language, and we'll go to basics of this, and it will take a bit time, but will be here. You can see they are talking about basic languages. Remember, this foundation of 8086 or 8085 basic languages can be used to program 8051 microcontroller. Almost same, but method is bit different, but terminologies are same. So this is somehow going to help you to understand microcontroller. We cannot get rid of one and get knowledge of others. This is typical embedded technology in Delhi University. This is quite elaborate, though in previous syllabus you found the topics are very in shortcut, and here you find only embedded system is in details. But remember, the previous syllabus will be complete when you talk in terms of this syllabus, because there is no shortcut to success, and I don't believe shortcut. I don't want to increase my viewers number by giving you quick version, and some of my students, I know, they get irritant with the lengthy process of understanding, but I have never found any shortcut to success. First it has to be intensive, and then it can be selective. Before exam you can be selective. So I never prefer shortcut to any knowledge, and I'll be fast, I'll be quickly moving, but it doesn't mean that I'll make shortcut to anything. Now, introduction to embedded system you have here. You talk about embedded system, you talk about classification, how it works, same story what I discussed in the previous syllabus. Then you have 8085 microcontroller, you talk about microcontroller in details. See the language program, again they are talking about assembly language. This is same as the 8085 or 8086 controller assembly languages we have. And then we have data type, different data types. It has to be systematic study, and I'll give emphasis when I'll discuss microcontroller. I'll give syllabus, I'll take this syllabus, and when I'll talk about microprocessor, I'll take the previous syllabus. Nowadays it's very common trend that give more emphasis to microcontroller. So we'll talk about programming, we'll talk about delay, and some knowledge of C language. Whatever is relevant I'll bring into highlight, whatever is required for you, and that will be discussed. Now next, this is not over with the syllabus, and we already talked about serial port. There are many things. Timer counter, same concept, and serial port, they are basically moving around same concept, but we have to handle it a bit carefully with systematic way, because exam point of view is more systematic. We have to be systematic. Then interrupts we will discuss. There are varieties of interrupts. We have priority of interrupts, this interrupt, that interrupt, which has got here they have mentioned here interrupt priority in 8051. Even in 8085, 8086 we have priority of interrupt. So we have to talk about that interrupt priority. Now let's talk about the interfacing. Interfacing is same as that of peripheral I discussed previously. So here you talk about interfacing, we are talking about peripheral. All the cases we discuss here, analog to digital and digital to analog conversion, and LCD interfacing. What we are doing in our laptop, when you see the things in LCD screen or in mobile, we do LCD. And remember, very interesting thing here, microcontroller is mostly used in mobile set, and the function of mobile nowadays almost same as that of desktop in some cases or laptop in some cases. They're so efficient. So the quality of microcontroller has increased, and we have inbuilt some memory, and we made it so efficient it's working almost same as that of microprocessor nowadays. Previously microcontroller was meant for very small work, like display of something in an electronics board, where we have small memory and that will run the show. But when we use microcontroller for bigger operations nowadays, and we are doing it successfully, sometimes we use more microcontrollers instead of one. And that technology, like robotics, embedded means we talk about robotics, where we use stepper motor and make the motor move according to our calculations in the programming. With this we can easily open the door, close the door, because motor can control any electromechanical substance, and we can make it move according to our choice. So this is what you have PLC, leading to this one concept is leading to PLC, automated industry, where we use robotics or automated packing system or any other system. So embedded technology is one of the most developing and most demanding technology, which we have to know very carefully, and we will discuss in details about this programming and applications of this. After this, I already started, if you remember, I started with this topic, and if you remember, I give you basics instruction how actually the computer works, that is data bus, control bus, and address bus. And we have CPU, the main structure of the computer, and we have the memory, and from the memory we have another structure, that is your input and output. These are the two things. The monitors and all are output, keyboard and mouse is the input. So data bus, control bus, see the directions. Arrow is very important. Here you give one arrow, one-sided arrow. Here from input you are giving something, and this is the arrow for control bus. There is two-way from input and output. From address bus, only address is given to the input. Input cannot take over your address bus, so address bus can give it to input. On the output side, you can see only it can be given to the output. Output can give to control bus, but that is a feedback actually. If output is not in a position to give you something, so they will just two-way. That is the two-way they are showing. Everything has got meaning. Try to understand those small things. Then address bus can give to output. So address bus is related, can give to input and give to data to output. And see the two-way, one-way, wherever it is applicable. And control bus is in all the cases you can see it is two-way, because control bus will also face interrupt, because if input you have some interrupt, it has to be given to the control bus. So from input it should come to control bus, and maybe some other interrupt occurs in your system, so control bus has to give it to input that don't give any more input. Or same with the output, it will give interrupt to output, no, stop now anymore, my function is not over yet. Same with memory, we have same story with memory, and we have same story with CPU. But CPU you can give to data bus, it has got double way, because CPU calculates and will give you something, it will take some data and give out some data. So for data bus it is two-way, for even control bus it is two-way, but for address bus CPU is of course one way, because CPU can give you address in the direction of address, but other way is not possible. Now very important terms are there which are very important for you all, because of especially those who are in BTech, they already have done this in digital, and those who are in BSc, they also have done, those who have basic electronics, they already have done these topics, and those who are from computer science, they must have done all these things, but even then it's quick revision. Small things we omit and that create problem. Bit, you have to be very clear about the meaning of bit. Word, again you have to be very clear about word, what they're talking about. Bit is a single binary. What is bit? If I talk about bit, you just 4 lights on. If you see my basic electronics lecture where I talked about digital, suppose I make this to be on, I simply have let me give example here only. I have 4 torches. One, no, sorry, I'll do it in different way to make it more clear. Suppose I have steel torches 1, 2, 3 and 4, and I make this to be on and this to be on, and I make this to be on, and I consider this valuation when this at night these two are on and these two are off. That means this is 1, this is 0, 1 and 0, and suppose I pre-estimate this is equal to A, and I again take another 4 torches and I make this to be equal to suppose I make this to be equal to on and this on, and both of them are off. So this is turning to you can say this is going to be 1, this is going to be 1, and this is 1, this is 1, this is 0, this is 0. We have particular rule in digital electronics. I am here taking random, and suppose that this is equal to B. So this is 1 bit. So this is in all, we can say 4 bit. Here I am explaining this to make you understand 4 bits. Word. A word is a word refers to the basic data size or bit size that can be processed by arithmetic and logic unit of the processor. A 16-bit binary number is called a word in a 16-bit processor. Listen carefully. If I take 4 bits, with the 4 bit I have serious problem. How many I can combine, I can present like this. First one is 0 0 0 0 and last one is 1 1 1 1. All 4 torches off is the first case, and that can be equal to 0, and all 4 torches on, that can be equal to some other number, the highest value. So if I go for permutation and combination, I can only represent 16 such combinations. You can find out. I can only go for with 4 bits. This is 1 bit. I can go for only with 4 bit. I can give only for 16 combinations. So how to handle the processing substances which has got more bit, require more bit. So I'll go for another 4. So that is 8 bit. Even that is not enough. After 8 I'll go for 16, and after 16 I'll go for 32, and after 32 I'll go for 64 bits. These terms are very much known to you. We are very sure about those terms because multiple of 4, because 4 bit will give you something. Now see the fun. If 16-bit processor, normally a processor is of 16-bit, and if you give something on 16-bit, automatically at one go it will work. So in that case we call that to be word, basic data size or the bit size that can be processed arithmetic or logic unit of processor. Directly it can be used when you have 16-bit processor. So we call it to be word. That means at one go which is processed is called as word. Now bus we know right now we discussed are the wires or lines that carry similar information. System bus is the system bus, means wires and line, communication between microprocessors and peripheral. Sometimes USB port is also a system bus. You can consider that to be system bus when you communicate the microprocessor with your peripheral. Now memory word, the number of bits that can be stored in a register or memory element is called memory word. See, your memory all has got different capacity. So number of bits you can store in a memory depending on your whatever you call it, ROM and RAM. We all know, we understand RAM has got 256 minimum memory. So 256 memory, look, I'll go in details of that, but now I'm giving basics of this so that you should be very clear with the terms. 256 means here they are showing you 2 to the power of 8. That means we have 256 bits that can be located. We have 256 different locations in case of address bus, but in case of memory word we have 256 memory bits as memory. So that much can be stored. Here, for example, here you can say in this case we have 4 torches, and with 4 torches we have only 4 bit as memory. Only 4 bits can be manipulated, 16 different options can be stored in this. That is your choice how you want to store it. Only 16 different choices can be stored in this. Now address bus is the same thing. It carries the address. You can say the address bus is same thing. We have 0 0 to FF. This is the case. 0 0 is this, and FF is the highest. FF is hexa. One should be very clear. This H indicates hexa. Hexa means 1 to 16 we count. How? 0 to 9 is first count, and then we come with A, B, C, D, E and F. E and F. So ultimately we come with the last word, 16th one is F. 0 to 9 is 10, 11, 12, 13, 14, 15, 16. So F is going to be 16. So FF means 2 bit with 16, 16. That's all they want to. This is 116. All are on. When all torches are on, that means it is F. Because we have 16 option. So first 0 to 9 option we have 0 0 0 0. All 4 0 means 0. And suppose say 1 0 0 0 is 1. Whatever it may be, we have a normal rule by which we follow. and last one is 1 1 1 1, all 4 torches are on. That is actually coming to 16th option. So 0 to 9 is the 10, and A is 11th, B is 12, C is 13, D is 14, and E is 15, and actually 16, because 0 is also 1, so F is 16th option. Data bus is, again, you have seen in data bus in all the cases. Control bus we have two way, in the data bus we found in some cases it is one way and it is two way. So you can see here clearly address bus is input output, it can be connected to input output, and it's in hexadecimal. And but data bus is actually, in case of 8085, it differs in different cases. 8-bit processor, that is 8085 processor, it is 8-bit. For 16-bit processor, that is 8086 processor, this is our 16-bit. So it depends on the what condition we have, what we have opted for, and address bus and data bus will take over according to that. Now this is sure certain, address bus is 8-bit, so we have 2 to the power of 8 is equal to 256 different locations for address bus. Control bus is, again, you can see the bus that controls, you have seen in all the cases input output address, it is two-way, so it goes with synchronization. That is very important for us. So after we discuss all this, we'll come to the conclusion. For the time being, next day onwards, I'll start directly with the syllabus. In fact, I have started with syllabus today with discussing these definitions, which are one of the prime concept of understanding. So thank you so much for listening.